Hello, everyone. Welcome to our webinar titled Exploring Common CDISC ADaM Conformance Findings. I'm very excited and appreciative that you have decided to attend this webinar and give me 45 minutes of your time. I hope you find it worth it. My name is Trevor Mankus, and I'm a product manager here at Pinnacle 21. I joined the company a little less than 2 years ago and primarily work to help shape the future direction our products take, as well as help answer any consulting questions related to ADaM implementation. I've been an active volunteer on the CDISC ADaM team since 2007, and I've been leading the CDISC ADaM Conformance sub-team for the past 3 years. Prior to joining Pinnacle 21, I worked at various CROs and pharmaceuticals as a SAS programmer since 2007. With that said, let's get started. If at any time you have a question during the webinar, click the chat icon in the GoToWebinar application. I'll save some time at the end of this webinar to go through your questions and provide as many answers as I can. Let's take a quick look at the agenda for today. I'll start with an introduction of why we're here. We'll take a quick look at some metrics that Pinnacle 21 has, and then we'll spend the majority of our time today looking at some common issues in ADaM in detail. And of course, then we'll summarize with conclusions and do some question and answer. So let's get started with our introduction. ADaM conformance. It's a lot, right? ADaM conformance can really be assessed by machine testable checks. The CDISC ADaM team publishes a set of machine testable failure criteria to help assess conformance with the ADaM standard. The problem is those machine testable checks really only get you about 90% of the way there. ADaM conformance is more than just executing machine testable checks. It requires a human element of manual review of the data versus the ADaM principles and core concepts. When we talk about machine testable checks, though, of course, there's a lot of benefits. So 3 of those key benefits is, obviously executing machine testable checks is fast, efficient, quickly reusable. You hit run on the application, you hit validate, and within seconds, you have an Excel spreadsheet with a summary of the findings. So you don't have a programmer sitting there reviewing the data record by record. The second key benefit, of course, is that machine testable checking software outputs in a standardized format. And that kind of leads into our third key benefit, which is using that standardized format, the reporting can be analyzed for patterns, right? So especially if that standardized format is in a machine readable file format, then you could pull all these reports together and start to look at which of these rules are occurring more often than others. And so how can this information be used, right? Okay, we have our standard format, we have hundreds or thousands of reports. Now I can start to analyze it. Well, what can I do with that information? And really, I've identified here 2 key things that you can do. So the first is maybe in your organization, you have a standards team. Something they could use this information for is they could actually develop standard issue descriptions that could feed directly into the reviewer's guide. So that the study team, when they go to validate their data, they know exactly what they can put in the reviewer's guide to help explain what this specific conformance rule, why it's firing. And secondly, this information can be used to really help identify areas where additional training material or supplemental training material would be beneficial. So if in my organization I recognize that study teams are really struggling with a specific concept of ADaM conformance, maybe that's where I need to develop some additional material to help educate them on how to do things correctly. When it comes to ADaM conformance, yes, we can run reports and yes, we can run software and yes, we can get reports, but I think the biggest challenge is really understanding those reports, right? You open it up, you see all the errors and issues that are there. What corrective action do I need to take to clear this up? And again, this is kind of where that human element comes into play. How do I fix this? What's the right way to fix this? And we'll dig a little bit deeper into that today as we get into some of these issues. So let's take a second to dig into our Pinnacle 21 data here and talk about metrics. So within Pinnacle 21, we have the unique ability to analyze thousands of data points from our customers. It's a very large sample size. And so we were able to look at that information, see which of these rules are occurring more often than others. Of course, we want to know which are they, why, and what are the potential causes. And again, this gives us the opportunity to suggest corrective action and come up with issue explanations, and even provide you with some sample text that could feed directly into the reviewer's guide. So the first issue we're going to look at in detail today is CT 2002, variable value not found in extensible code list. This rule in particular was probably the most common. It was found in about 70% of our data packages that we analyzed. And because that's such a large number, I didn't want this entire webinar to be just about this rule. So instead, I broke it down into two of the most prominent use cases. So we have the race variable in ADSL, and then this rule was also firing for the D-type variable in our basic data structure data sets. So we'll dig into those two use cases now. The first one for the race variable in ADSL was found in about 62% of those data packages that I just talked about. So this one in and of itself was very, very common. And so the logical question is why, right? Why is this showing up in so many of our reports? Well, let's take a step back and read through the material that's specified in the ADaM implementation guide and the SDTM implementation guide. Okay, so the ADaM IG mandates that the race of a subject is a required variable in ADSL. And really what that just means is if you have an ADSL data set, it has to have a variable called race. Furthermore, the values of that variable must be identical to the values of race found in the demographics SDTM domain, DM. Now, when I say it must be identical, it has to be an exact copy. Okay, you can't manipulate or change or add or edit or modify these variable values. This is really one of those things that we talk about in ADaM called the principle of harmonization. And it's kind of got a mantra, same name, same meaning, same values. And again, all that means is if it's defined in SDTM, carry it into ADaM and don't touch it. Okay, has to be identical. So since it has to be identical, let's take a look then at the SDTM implementation guide. Well, the SDTM implementation guide tells us that the race variable is subject to control terminology. The code list it must adhere to is called race, and that code list is non-extensible. So let's take a look at the values that are in that code list. Okay, as of this webinar, there's 7 values. We have American Indian or Alaska Native, Asian, Black or African American, Native Hawaiian or other Pacific Islander, and then we have not reported, unknown, and white. So the real problem here is that the SDTM implementation guide describes 3 additional scenarios. The first of those says, if multiple races are collected on the CRF, then set race equal to a value of multiple. And if we go back, we'll see that multiple is not a value on this code list. And again, this code list is not extensible. The next scenario says that if race is collected on the CRF via an other specify field, set the value of race to other and use the supplemental qualifier domain for DM to describe the details of the other specify. And again, if we go back a slide, you'll see that other is also not a value on this code list. And the third scenario simply says, if a subject refuses to provide race information, set the value of race equal to unknown. And now this one is actually covered on that code list. You'll see it's the second value from the bottom here. So we have 3 additional scenarios described in the IG, 2 of which give us direction to set it equal to a value that is not in the code list. So what do? Well, simply said, that this just highlights some of the discrepancies between the NCI code list and the CDISC SDTM implementation guide. Again, the IG specifies scenarios where you would set the value of race equal to multiple or other, and these values are not represented on the CT, the code list for race. So how does Pinnacle 21 address this? Well, what we've done is we've actually implemented to match the standard, the SDTM implementation guide. Okay, so we want to consider values of multiple and other as valid. And the way we do that is we've actually considered this code list as extensible, even though the NCI team says it's not. We treat it as extensible, and also then when this error shows up, we treat it as a warning as opposed to an error. Okay, and this is the best way that we could support the standard, the SDTM IG, while this discrepancy is out there between the code list, the published code list, and the implementation guide. So let's take a look at the sample explanation we can put in our reviewer's guide for this if it were to fire. Throughout the rest of this webinar, you'll see this table. The structure and contents of this table as far as column headers was taken directly out of the Fuse Analysis Data Reviewer's Guide template. So we just specify the data set, the message or check ID, the severity, the number of records that this issue fired for. So we have 2 records in this example. And in the far right column, I've just provided a very brief explanation. It simply says, both of these subjects selected other specifier on the CRF, and per the SDTM implementation guide, we set race equal to other, and the details of the race can be found in sub-DM. Okay, so very short and sweet, very concise. And all we're simply doing is saying, hey, we followed what's in the SDTM implementation guide. Now let's take a look at the next use case for CT 2002, and this has to do with the D-type variable in our BDS data sets. So this one wasn't nearly as common as race, but it was still found in about 8% of the data packages that were out there. And so the question now is why, right? Well, let's look at the documentation. So the ADaM implementation guide states, D-type is used to denote and is required to be populated when the value of AVAL or AVAL-C has been imputed or derived differently than the other analysis values within the parameter. Okay, so long story short, what that means is if AVAL or AVAL-C was derived or imputed, D-type has to be present and should have a value. Okay, now the ADaM implementation guide has D-type subject to control terminology against the D-type code list, and that code list is extensible. So if we see this fire for our study, what's some of the corrective actions that we can take to rectify this? Well, the first and very obvious one is verify that the value you're using is part of that code list. Use use the most appropriate value, right? So if your imputation method is taking the worst score and filling in the missing with the worst score, don't use a D-type value equal to worst. Instead, use WOCF, which stands for worst observation carried forward, which is on the CT, which is part of the code list, right? So you want to use the most appropriate value for your derivation method. Once you've identified that you're using the most appropriate value and you're still seeing this, then I would say check the case and formatting against the CDISC submission value from the CT package. This is case sensitive, okay? So if you're using mixed case or lowercase in your data and the code list has uppercase, that will cause this rule to fire. So you want to make sure that this is following letter for letter against the CDISC submission value. Third is, use a descriptive value. I see this happen a lot where people are setting D-type equal to just a value of derived. And it's very common and very incorrect. And the reason it's incorrect is because just the presence of a value in D-type alone, regardless of the value, indicates that the value was derived. So setting D-type equal to derived is just redundant. Instead, the value in D-type should describe how it was derived. Was it the minimum, the maximum, the average? How was it derived? What algorithm was used? So avoid using just a generic term of derived and instead use something that's more descriptive. And of course, if everything is good, go ahead and document in the ADRG, right? So for this case, for the explanation, I said for this study, D-type was set to some, which is not part of the D-type code list in this ADaM terminology package that I used. And then furthermore, I go on to briefly describe what a value of some means by saying that it indicates AVAL or AVAL-C was derived simply by adding values from prior observed records. Okay, and then at the very bottom of this, I even go on to say, refer to section 3.6, which again, if you're using the Fuse ADRG template, this section right here is reserved to describe how D-type was used in which data sets and what values are there. And then it gives you an opportunity to describe, what those values mean. Okay, so I'm kind of throwing back to section 3.6 for more information. So I think in this case, the more the merrier, the more information, the better. And even if it's a little redundant with section 3.6, I still think that's okay. Let's move on to the next rule that we see a lot of, and that's AD0047. Required variable is not present. All right, so this rule in particular was found in about 51% of data packages. The rule itself is a simple one. It's intended to just check that the presence of all required variables described in the IG are there. Okay, so if a variable is marked as required, it's present in that data set. And I think the leading contributing factor for this rule firing is mainly because the set of required variables defined in the implementation guide is very much dependent on dataset class or dataset classification. So you're going to have different variables that are required for ADSL and BDS and OCCDS. And so that's going to be the focus of the next few slides. So the purpose of this table here was just to kind of briefly highlight what variables are required based off of dataset class. And again, this is based off of ADaM IG version 1.0. Well, ADaM IG version 1.1.0 and OCCDS 1.0. So for ADSL, we have study ID, use subj ID, site ID, age, AGU, sex, race, arm, and plan treatment for period 1. And for BDS, we have again study ID, use subj ID, and then param code, param, and treat P. And when we talk about ADAE, we're looking for the presence of study ID, use subj ID, AE-seq, AE-decode, AE-BODSIS, AE-term, and AE-SER. And then for OCCDS, we have a very short list. It's just 3 variables: study ID, use subj ID, and some sort of sequence variable, --seq. Okay, so why is this rule firing? Why are we seeing it so often? Well, I think, again, the contributing factor for this is likely because the requirements change between IG versions. One of the most common mistakes, and I think the biggest change between IG 1.0 and 1.1, and even IG 1.2, is that in IG 1.0, treat P was the only variable required in a BDS dataset. I'm sorry, treat P must be present in BDS datasets. It wasn't the only required variable. But as far as treatment variables go, it was the only required treatment variable. And once we expanded into IG 1.1 and now IG 1.2, that requirement was loosened up. So it's no longer just that treat P must be present, but instead we've given a list of, I think it's about 15 or more variables. So it says at least one treatment variable is required in a BDS dataset, and this is satisfied by any of the subject level or record level treatment variables. Okay, so the requirements are changing across IG versions. I think another contributing factor to why this rule showed up as one of the more prevalent ones was due to a lot of false positives. Some of the early versions of our software, Community 2.2 and earlier, and even some of the earlier enterprise versions, incorrectly identified occurrence data structures and ADaM other data structures as basic data structure. And what that would mean is you'd end up with a record in your report that says param or param CD is missing. And you'd probably scratch your head a little bit and say, well, this is an OCCDS data set. We don't need those variables. And so that kind of goes back to one of the first few slides I had, was the biggest challenge is kind of understanding these results and what the corrective action is to take. And so we heard you, we got your bug reports, and this was fixed well over a year ago. And so we shouldn't be seeing this as often anymore, especially if you're using some of our newer software versions. But I wanted to use the second half of this slide to go over how we at Pinnacle 21, how our validator identifies dataset classes. Again, because the set of required variables is so dependent on dataset class, I thought that this information would be informative. And this table is actually split out by agency. So we have FDA and PMDA. So for ADSL and ADAE, it's very straightforward, right? We're just looking for a data set that's named ADSL or a data set that's named ADAE. And for BDS, any data set that contains any of these 4 variables, param CD, param, eval, or eval-C. The big distinction here is that for FDA, OCCDS gets recognized as long as the data set contains --treat or --term, and of course doesn't contain param code, because that would be BDS. However, you'll notice PMDA has a blank value in this column. And that's because PMDA does not yet recognize OCCDS per their latest validation rules. And then lastly, we have ADaM other, and that's simply going to be any data set that wasn't already identified using these previous rows in the table, and the data set also must begin with an AD prefix. Okay, so we have this message fire. What's the corrective action we should take? Well, again, the obvious one, review the requirements and update your data set if needed. And of course, if you can't, or if you feel like there's no corrective action that needs to be taken, document in the ADRG. And so I kind of used some of the false positives I talked about earlier as an explanation here. And it's probably something that you've seen in your own time if you were using those earlier versions of our software. It's just as simple as saying, hey, this data set's an OCCDS data set that was incorrectly identified as BDS. Furthermore, per the occurrence data structure document, the param variable is not required or appropriate for this class. So again, you're always trying to point back to some sort of standard document that says why, to justify why this is. All right, let's move on to the next rule that we see a lot of, and that's AD0019, variable label mismatch between dataset and ADaM standard. Now, this rule in particular was found in about half of our data packages that we analyzed. And it's very simple. All it does is validate the variable label in the data matches the standard variable label in the published document. One of the most common causes, I think, for this rule is due to some of the smaller changes that occur across IG versions. So the CDISC ADaM team, as they revise these documents and produce new versions, are making small tweaks to some of these labels, in many cases for good reason. So we'll go through these pretty quickly, just for the sake of time. So we have ANLZZFL, it's our analysis flag variable. And in IG 1.0, the label was analysis record flag. And in IG 1.1, we removed the word record and just made it analysis flag. For the next two variables, AOCCFL and ADER-N, the label of these actually changed when OCCDS was derived from the ADAE document. So in ADAE document, the labels for these variables were specific to adverse event. And there's references in the label to AE flags and AE duration. And when the CDISC ADaM team decided to make the ADAE document more generic, of course, the labels for these variables had to change as well. And so we removed references to AE and instead made them more generic labels. I think one of the biggest contributing variables that for this rule are the date time variables. So any variable that ends in DTM, that's numeric. We actually have four different flavors, four different documents for this one. So both IG 1.0 and OCCDS 1.0 have DTM variables with a label of date/time. And in IG 1.1 and OCCDS version 1.1, we have date time, one word. So very different, and this is an important distinction to make, right? So if you have a DTM variable, make sure you're using the right type of label. Also on this slide, we have eval cat y. We added the word value. So now we have analysis value category. And for p change cat y, we added the word category at the end. And because we added the word category, we were also then forced to change or abbreviate the word change to be CHG, just so we could stick within that 40 character limitation. And lastly, we have source DOM. The label was changed from source domain in 1.0 to now be source data in IG 1.1. And that just makes it more generic so that you can reference ADaM data sets in source DOM. And then for start date, the document added hyphens between IG 1.0 and IG 1.1. So instead of time to event without hyphens, now we have time to event with hyphens. So again, some very minor differences here, but I wanted to highlight these in this webinar because I think some of these contribute to why we're seeing this error so much. Furthermore, section 316 of the ADaM implementation guide talks about two specific exceptions to when variable labels don't have to match the standard. Okay, so we'll go into a little detail now about what these two exceptions are. And the first has to do with variables that contain index placeholders, or more simply put, variables that contain Y or ZZ. A good example of this is analysis flags, ANLZZFL. So According to the IG, the label for this variable is analysis flag ZZ. And you can imagine that's not very descriptive, right? Analysis flag 05. Well, what does that mean? What's the algorithm that's being used to flag these records? So we can actually producers can actually add text after the standard label to make it more clear. So analysis flag 01 thromb event for a specific type of AE. And this can be helpful, especially when you have a lot of flags. So maybe you have like 15 analysis flags. Wouldn't it be nice if you could just look at the label and know what flag is for what purpose? But also if you're doing any sort of integrated analyses and you're pulling together, a bunch of different data sets, you want to make sure that your analysis flag 5 is the same derivation across all your studies. Okay. Now the second exception to the label rule is for any of the variables that are defined in table 3.3.3.3. And these are actually just suffix timing variables. So any variable that ends in these suffixes must have the string that's within the brackets somewhere in the label. So a couple examples of this, right? Star ADY. Any variable that ends in ADY has to have a user-defined label that contains relative day somewhere in that label. Another example is for SDTM, star SDTM, which is start date time. Again, your user-defined label can contain anything it wants as long as somewhere in there start date time is present. And it's worth noting, you can't have start something date time. Start date time has to be next to each other. Has to be not split up. Okay, so what kind of corrective action can I take for the variable label mismatch? Well, update the label to match the standard, right? That's the easiest. Review the casing and formatting. Again, this is case sensitive. Make sure it's an exact match, no extra spaces. Make sure you have hyphens where you need hyphens. And if your variable falls under exceptions 1 or 2 that we just talked about, then go one step further and ensure the label matches up to the producer-defined text, up to where that starts, okay? And then lastly, of course, if everything looks like it's on the up and up, just document it in the reviewer's guide, why this is happening. Okay, let's take a look at one more rule. This is AD0124, inconsistent value for parcat within a unique param CD. Now this rule was found in about 24% of our data packages. And the rule validates the relationship between two variables, parcat Y and param CD. And the relationship between parcat Y and param CD is a many-to-one relationship. Okay, and what that means is that any given value of param CD can map to only one value of parcat Y. And I have an example of this in a couple of slides. So why is this happening? Okay, well, I think the main contributing factor to this is that producers of ADaM are so used to the relationship between SDTM category and SDTM test code that they don't fully understand the difference when it gets to ADaM between the parcat Y and param CD variables. So many times we are just setting parcat Y equal to SDTM category and param code equal to SDTM test code. And that's incorrect. It's very common and very incorrect. Care must be taken to ensure uniqueness and to ensure that that relationship is correct. So on this slide, I have an example on the left of the incorrect way to have this relationship, and on the right, the correct way. All right, so on the left, we simply set our ADaM variables equal to our SDTM variables, okay? And we end up with glucose that that has PARCAT 1 values of urinalysis and chemistry. And this is incorrect. Okay, we have one param going to many parameter categories, when in fact, that relationship has to be many to one. So it's the opposite. To correct that, what we can do is we can simply make a distinction between these two types of glucose records. And so the way we chose to do it in this example is we just appended a U to the front of our param code, and we went one step further and we modified the values in param to be more descriptive. Okay, and the reason for that is because in ADaM, all of the qualifying values that describe your analysis value must be in param. And the distinction here is that in STTM, they can exist in different variables. You can have category, and you can have position, and you can have, all those other qualifiers. But in ADaM, they all have to be a part of param if it helps distinguish the analysis value. And so what we did is we called urine glucose millimoles per liter for urinalysis, and we called param blood glucose milligrams per deciliter for chemistry. So let's jump over to some conclusions. The first thing I want you to walk away with from this webinar is that organizations can certainly benefit from analyzing these reports. Again, looking at our standard reporting structure, machine reading them, and pulling information out will help identify areas of focus for supplemental training for your staff, but also might help with other things like providing standard issue explanations in your reviewer's guide. And the thing I really want to drive home is that ADaM conformance is a lot more than just executing some machine testable checks. Okay, again, it really takes that human element of expertise to take a look at the data and make sure it adheres to those core ADaM fundamental principles to ensure compliance. And lastly, document. Okay, the analysis data reviewer's guide is an important piece of the submission puzzle. It's one of, if not the first document that a reviewer is probably going to open when they start to do their work. Okay, so yes, it's probably going to contain a lot of duplicate information from your protocol or SAP or any other document out there, but that's okay. It's the one-stop shop for a reviewer. That being said, we have about 4 minutes left. I'd like to take a look at some of the questions I've gotten from you guys and take a stab at answering those. Let's see. So here's a good question. It's why do FDA and PMDA have different ways to identify ADaM dataset class? So that's a great question. So I think for this one, the major contributing factor for this isn't necessarily related to the agency, but again, rather to the implementation guide versions that they accept. So as of today, FDA accepts ADaM IG 1.1, maybe even 1.2. I need to go back and check. And ADaM IG 1.1 includes the occurrence data structure as a valid data set class, while PMDA currently only accepts up to ADaM IG version 1.0. And so that's really the important distinction of why PMDA will classify those OCCDS data sets as ADaM other, is because they don't yet have any rules that are really applicable to OCCDS. Okay, so it's not necessarily the agency, but more just the accepted IG versions that they're currently have in their catalog. Next question. So, do all findings in my validation report need to be described in the RG, the reviewer's guide? It's a great question too. I don't know that there's a real specific guidance that I can cite for this, but what I can say is, again, from my experience, what I would recommend as the best practice is yes. You know, and I know that can seem overwhelming and cumbersome. I'd say at a minimum, you have to include the errors and the more severe things in your ADRG. And I might be wrong on this, but I'm pretty sure it's section 6.2 or 6.3 of the Fuse ADRG template is a spot where it's called issue summary, and you can actually use this section to fill out the same tables that were in this webinar, right? This data set had this rule fire for this many records, and here's why. So again, I would say best practice is the more the merrier, right? It doesn't look like you're hiding anything. It looks like you've done your job. It looks like you've done a full fitness assessment of the data conformance. And as a reviewer, I think that would make me feel more comfortable. So I would say best practice is yes, do that. And in addition, you know, you can run additional checks as well. So even if you do that, you know, human element of manual review, note that, put that in your reviewer's guide. Even if you have some homegrown checks, note that, put that in your reviewer's guide. And I think we have time for probably one more question, unfortunately, and then I'll try to do my best to answer the rest of those and get them posted to our website, because they're coming in fast. Let's see. So here's a good one. What if the value I want to use in the D type variable is not part of NCI? So I did talk a little bit about this. The code